Now I'll study the intensity of spectra. It depends on the selection rule. A set of quantum mechanical rules which control the transition is the selection rule. All the spectra following the selection rule are intense, and each spectra is controlled by a different selection rule. Any delta n can be any number. Delta L if it is plus minus 1, it follows the Laporte selection rule. If delta S is 0, it follows the spin selection rule. This is the trick to remember which transition are possible and which are not. For example, if we write SPDF, then all the horizontal are allowed. Example SP or P to D, D to F, or D to or F to D, D to P, or D to S. All diagonal are allowed. Example S to P, P to D, D to F, or vice versa. But all verticals are not allowed. Example S to S, P to P, D to D, or F to F are not allowed. And all jumping are not allowed. Example S to D is not allowed, P to F is not allowed. For example, fixing colors, example paint, pigments, chlorophyll, they follow the selection rule, that is charge transfer mostly. That is there are allowed transition in these. Example CDS, it is a yellow metallic compound, and non-fixing color which undergoes partially allowed transition, gives non-fixing color. Now the second point is intensity of selection rule. It depends on population difference between two states. That is, it is directly proportional. If the higher population difference, then more is the transition and the probability will be higher. Therefore, more absorptions and higher intensity. For example, this has more intensity because the probability is higher of transition because the ground state is more filled. Now population gap is given by Boltzmann distribution law, which is Nu upon Nl is equals to Gs exponential minus delta E upon Kt, where Nu is population of higher state, Nl is population of lower state. Delta E is energy gap between two states, K is Boltzmann constant, which is 1.38 into 10 raised to minus 23 joules per Kelvin. Gs is Landau splitting factor, which is 1 except for rotational. This is the NL population of lower state. This is a new population of upper state. This is the energy difference. For Nu is equals to NL, T will be infinity, which is not possible. Delta E is equals to 0, that is degenerate levels, it is not required. Therefore Nu is not equals to NL. Nu, that is population of upper state, is always less than population of lower state. Now intense beam, that is laser, it is the light amplification by stimulated emission of radiation. Intensity is of UV is more than IR, then rotational, then least is for NMR and ESR. Intensity is less. Now the lower the temperature is, the more the intense spectra will be, because the ground state is filled in case of lower temperature. Now that's why the intensity of UV is more. That's why it's the UV machine is of 25 to 35 lakhs, but NMR, since its intensity is very low, it is a very costly machine of around 8 crores, and intensity is inversely proportional to temperature. That's why at lower temperature more intense spectra we get, and it is directly proportional to the energy.